Pre-calculus 5.1 day 2 for students who were absent. And so our warm-up here is to combine number 1, these fractions, get a common denominator. And so the common denominator is going to be the product xy. So you need to multiply the first fraction by y over y, and you need to multiply the second fraction by x over x. And so then you get a common denominator of xy, and you get 2y plus 3x. So that's just getting common denominators. In number 2, we have complex fractions. And so what we're going to do is get the numerator to have one fraction and then multiply by the reciprocal of the denominator, because when you divide, you multiply by the reciprocal when you have fractions. And so the common denominator just for the numerator is going to be c times s. And so we're going to have s over c. We're needing to multiply that by s over s. Plus we have c over s, and we're going to need to multiply that by c in the denominator, so c in the numerator. And that's just going to be all over 1 divided by s squared. So in the numerator of that fraction, we're going to have that common denominator cs, and we have an s squared plus a c squared. And again, that is all over 1 over s squared. You need to make sure that your major fraction bar is longer. Sometimes it's helpful to maybe put parentheses around the numerator and denominator just to make the communication clear. But when you divide fractions, so we have this numerator. When you divide fractions, you multiply by the reciprocal. So I'm dividing by 1 over s squared. So what happens is you multiply by the reciprocal. And on that, then this s can take out one of those, and we have s times s squared plus c squared all over c. And so at that point, I could distribute the s, but I can't cancel anything. And so because of the addition of that second quantity. And so that's it. That's what I can do with that. There's nothing else really to do with that. S squared plus c squared times s all over c. All right, in 3, it says to factor. Well, the numerator is factored, but in the denominator, I have a difference of squares. And a difference of squares factors a plus b times a minus b. Only, we've got cosine of x squared and 4, which are both perfect squares. So on this one, the numerator is cosine of x minus 2. Don't forget that argument of x. In the denominator, because I have a difference of squares, I can make it cosine x plus 2 and cosine x minus 2. Now when you go to cancel these, I sometimes see people go this cosine with that cosine, that 2 with that 2. That's not correct. That's not the way to think about it. You need to, I'm back this up, you think of it as this as a factor cancels that as a factor. And what I am left with here is a 1 over cosine of x plus 2, and that's how we need to leave it. So one thing just from the beginning of number 3, sometimes people think they can take that cosine and make that a cosine of x. That 2 goes in there and makes that a 2. That is not correct. You have to have products of things in order to be able to cancel factors. And we have a difference in the numerator and a difference in the denominator. So that kind of cancellation is illegal. So make sure on these you start with the original problem, work down the page, start each line with an equal sign as you work that. All right, so in class we did the warm-up, and then we did some of these examples, leaving, a couple of them for students to do. And then these were uploaded as homework by the end of the class. So example 1, rewrite with the least number of terms. And one of the techniques that we often use is rewrite in terms of sine and cosine. It's not always the case, but that is something that we use. And so in part A, you write the original problem down, and then we're going to go, well, secant is 1 over cosine theta. Don't forget the theta. And then that's times cosine theta, and I can think of that as over 1. And so that becomes, when you multiply fractions, you multiply the numerators and the denominators, so you get cosine theta over cosine theta, which simplifies to 1. In part B, we've got this mixture. We don't have anything squared where we can replace with a Pythagorean identity at this point. So what we're going to do is rewrite cotangent as cosine over sine. So cosine theta over sine theta is cotangent theta. And then I have sine theta I can think of as over 1. And when you have multiplication, you can cancel those sine thetas. So you have cosine theta over 1, which is just cosine theta. Part C. We have secant, sine, and tangent. None of them are squared. There's nothing as a common factor that I can pull out. So I am going to write the original problem down and then change things in terms of sine and cosine. So the reciprocal of secant is cosine, so secant is 1 over cosine theta, minus, then I have sine theta over 1 times tangent theta. And tangent is sine theta over cosine theta. So I have 1 over cosine theta minus sine times sine is sine squared theta, and in the denominator 1 times cosine is cosine theta. So they have a common denominator of cosine, so I can go ahead and subtract the numerators and put them over cosine. But wait a minute, 1 minus sine squared. We have sine squared theta plus cosine squared theta equals 1. If I solve that for cosine squared theta, that Pythagorean identity, cosine squared theta is 1 minus sine squared theta. So I can replace 1 minus sine squared theta with cosine squared theta. And then this cosine in the denominator takes out one of those in the numerator, and you are left with just cosine theta. So you work through D and show the steps. And when you get done, the answer to this should be sine squared theta. So see if you can get to that. Oops, maybe I have the wrong one. Just a second. Yeah, scratch that. I have, I think that what we wanted was the denominator on that to be secant theta. Just double checking. Yeah, change this to secant theta. Then the answer is going to be sine squared theta. I just had an error in the notes and I hadn't caught it till now. So change the denominator to be secant and then work that, and the answer should be sine squared theta. All right, so part E, we have some other Pythagorean identities. Right here we have secant squared theta minus 1 over secant squared theta. Because of the subtraction in the numerator, you cannot cancel out secant squared and secant squared theta. It has to be a product of things in the numerator before you can cancel. And we don't have a product, we have a difference. So that would not be a legal move. But the secant squared theta minus 1 brings back to mind that we have a Pythagorean identity. 1 plus tangent squared theta equals secant squared theta. And if I solve that for tangent squared, that's going to equal secant squared theta minus 1. So I can replace secant squared theta minus 1 with tangent squared theta. So that's what I'm going to do. And so I have tangent squared theta over secant squared theta. Well, at this point, I'm going to go ahead and I'm going to change these to in terms of sine and cosine. So tangent squared is going to be sine squared theta over cosine squared theta. That's your numerator. All over secant squared is 1 over cosine squared theta. And so when you divide those, you multiply by the reciprocal. So I'm going to take the numerator, sine squared theta over cosine squared theta. That's divided by 1 over cosine squared theta. But again, instead of dividing with fractions, we can multiply by the reciprocal. So I'm going to multiply this by cosine squared theta over 1. And since this is multiplication, I can take that cosine squared and that cosine squared and cancel, and that leaves me with sine squared theta over 1, which is just sine squared theta. And as you're writing these, make sure you include the theta as the argument as you work through. And then I'm going to leave you to do part F. You should get down to the answer being cosecant squared theta. So there you have it. And you have the answer in part D and the answer in part F. Make sure you do that correction for part D. That should be cosine theta over secant theta. And then you have it. Finish them up, and that's what's due to be turned in for notes.